my group members.
My name is Afif Mikail bin Roshadi.
My name is Muhammad AIMAN bin Muhammad NOOR.
My name is Muhammad ADNAN bin BAKRI.
We'll continue with the data analysis and conclusion. This project is to analyze the relationship between diet type and disease resistance among variants using basic statistical method. In this study, we use dataset A, which consists of 200 observations. The dataset involves us to categorical variables. The first variable is diet type, which includes diet A, diet B, and diet C. The second variable is disease resistance, which is specified as resistant and non-resistant. This project aims to apply statistical concept that we have learned in class, particularly in organizing data using a chain frequency distribution and performing hypothesis testing. The objectives of this study are first to summarize the relationship between diet type and disease resistance using a chain frequency distribution error. And the second, to determine whether there is a significant relationship between diet type and disease resistance by applying an appropriate statistical hypothesis test.
So let's move on to the data analysis. So this is the research question. Is there a significant relationship between diet type and disease resistance among patients? So let's move on to the observed frequency. Oh, before I forgot, the null hypothesis is diet type and disease resistance are independent, which means it is no relationship. For the alternative hypothesis, diet type and disease resistance are dependent, which means it is as relationship. Now let's move on to step 1, observed frequencies. Observed frequency are the actual number of patients recorded in each category, taken directly from the dataset. After summarizing the data using Microsoft Excel, we obtain the following joint frequency distribution table. So as you can see, resistance A is 50, resistance for B is 49, resistance for C is 48. The total is 147. For non-resistant, for A 17, for B is 18, C is 18, and the total is 53. And for the total, you will get 200, which is equal to the question. Now let's move on to the step 2, expected frequency. Expected frequency represents the number of observations we expect if the null hypothesis is true, meaning there is no relationship between diet type and disease resistance. So let's write the formula clearly. E equal to row total multiplied by column total, and we will divide by grand total. This symbol E is pronounced as expected frequency. The horizontal line in the formula is called a fraction bar, and it means divided by. Now let's move on to the step 3. Calculate expected frequencies. Let us start with diet A, resistance. So E equal with 67 from here, multiplied by 147 here, divide by 200, and you will get 49.245. Next, for diet A non-resistant, E equal to 67 multiplied by 53 and divide by 200, you will get 17.755. For diet B, the row total is the same, which is 67. So the expected frequencies are the same. So we move on to the diet C. Diet C resistance E equal to 66 multiplied by 147 divided by 200, you will get 48.51. And for diet C non-resistant, E equal to 66 multiplied by 53, you will divide by 200, you will get 17.49. Now let's move on to the step 4, expected frequency table. After calculating all the expected frequencies, we summarize them into a table. So as you can see here, for resistance A is 49.245, for B just the same as A, and for C 48.51, and for the non-resistant A 17.755, B equal to A, and for C is 17.49. So all expected frequencies are greater than 5. Therefore, the assumptions of the chi-square test of independence are satisfied.
Okay guys, now we proceed to step 5, which is to write the chi-square test. So this is our symbol chi-square test. This symbol test is pronounced as a sky. So x square is pronounced as a chi-square. So for this symbol is pronounced as a sigma, which is means sum of. And for this symbol represent of the frequency, and the symbol is an E symbol represent aspect frequency. So now we move to step 6, which is calculate the chi-square value for each cell. So diet A resistance 50 minus 49.245 square divide 49.245, you can get the answer 0.0116. For the diet A non-resistant, 17 minus 17.755 square divide 17.755, and you can get 0.0321. Okay. So for the diet B resistant, 49 minus 49.245 square divide 49.245 equal 0.0012. For diet B non-resistant, 18 minus 17.755 square divide 17.755, and you can get the answer 0.0034. For the diet C resistant, 48 minus 48.51 square divide 48.51, you can get the answer 0.0054. And the last one, for the diet C non-resistant, 18 minus 17.49 square divide 17.49, you can get the answer 0.0149. Okay, now we move to step 7, which is we need to sum all the calculate values. So x square equal 0.0116 plus 0.0321 plus 0.0012 plus 0.0034 plus 0.0054 plus 0.0149, and you can get the answer is 0.07. Now we move to step 8, which is calculate the degree of freedom. So the symbol is degree of freedom. So R minus 1 times column C minus 1, and you can get the answer is 2. So the last step is decision using p-value. H square equals 0.07, and degree of freedom equal is 2. So using Microsoft Excel, the p-value corresponding to the chi-square statistic is 0.91. So therefore P is greater than 0.05.
To conclude this topic, the decision rule states that if the p-value is less than or equal to 0.05, we reject the null hypothesis. If the p-value is greater than 0.05, we fail to reject the null hypothesis. Since the p-value of 0.91 is greater than 0.05, we fail to reject the null hypothesis. In conclusion, there is not significant relationship between diet type and disease resistance among the patents in the study. This suggests that based on the given data, different diet types do not significantly affect disease resistance.